Hello everyone, welcome to Clashing Coder. So in this video we will see the question search in a matrix. So this is an easy level question and it has been asked for various interviews for various big companies. So let's see, you can see the company tags from here. So you can see it has been asked in Adobe, Amazon and Goldman Sachs, and you can see Visa, Oracle and lots of companies. You can see Paytm. So this question is really important in from the perspective of interview, for the coding interview in the big companies. So let's see what is the problem statement, and I will also clarify you that this problem is somewhat different from the problem given on that lead code. So I will make a video for the lead code problem, that is such a 2D matrix after this part. That will be the second part for this video. So let's see what is the problem statement and on the Geeks for Geeks, and then on the lead code. Then we will solve the question for the Geeks for Geeks. So let's see. So the problem statement is given a matrix, that is mat. You can see it is a 2D matrix of size n into m. So n are the rows and m are the columns, where every row and column is sorted in increasing order. So that means we are given a matrix, 2D matrix, where every row and column are sorted in increasing order. So you can see this is a particular row. So you can see all the elements are sorted, okay, in increasing order. And for this row also you can see all are sorted, and this row also you can see all are sorted. And the column wise also the matrix is sorted. You can see 3, 44 and 57, 30, 52 and 60. So you can see these are column wise also sorted, row and column wise sorted. The task is to find whether element x is present in the matrix or not. So that means we have to search for an element. As you can see, it is a search in a matrix. So we will be given a 2D matrix which is row wise and column wise sorted, and we are given a number that we have to find. And you can see output is given 0. So that means the number we are given is 62. So you can see 62 is not present in this matrix. So we will return 0. So that means we are given, you can see, a function where we have been given the matrix, the rows and columns, and the element that we have to search for. And we have to return 0 if the element is not present in the matrix. Otherwise we have to return 1. And you can see from here also what is our task. And the expected time complexity for this question will be O of n plus m, and the auxiliary space will be O of 1. And you can see the constraints. So rows and columns will vary from 1 to 30, and you can see the matrix elements will vary from 1 to 100, and the element that we are searching from will also vary from 1 to 100. So what is different in this question is here we are not given the constraint that the first element of the next row, that is this, if we are on this row and the first element of this row, that is 44, is greater than the last element of the previous row. So we are not given that constraint. So in the lead code you can see we are given the constraint that if the row wise, the matrix is row wise and column wise sorted, and also the last element, that is the 7, okay, the last element of the previous row is less than the next less than the first element of the next row, you can say 10. So here the elements are sorted in this order also. That means 1, 3, 5, 7, and then after 7, 10, 11, 16, 20. So if we write this as, if we like spirally traverses like 1, 3, 5, 7, and then 10, 11, 16, 20, and then again 23, 30, 34 and 60. So this will be also sorted in, it can be formed in sorted way. You can see it is written 1, 3, 5, 7. So this is sorted actually, you can see. So here our solution can be more optimized than the solution on this problem statement. So this is the difference between both the questions. So if you are asked this question in an interview, so you should confirm from the interview whether we are given the constraint that the last or the first element of the next row is greater than the last element of the previous row or not. So that means if it is that, then I will explain, I will make a different video for this, that will be part 2. So do subscribe my channel, and click that notification bell for if I make this video. So I will upload it in 2 to 3 days. So you will be getting you will get to know whether I have uploaded it or not. So do watch this video before watching that video, and you should like prepare for both the questions if you are asked in an interview. So let's see how we can solve this question. So the naive approach that can be used for this question is simply traversing the matrix using 2 for loops, because we have to find for the element if it exists in a matrix or not. So if we are given 62, so what we can do is we can run 2 for loops. You can see I have written the pseudocode here. We can run 2 for loops. First for loop will be for rows. So I will be running for rows. You can see it will be running like this, and J will be running from the columns. For the columns, you can see J will run for the columns. Then we will check A is actually our matrix. So we will check A of ij is equal to number. If the number that we are given, that is 62, is equal to any of the elements, so that means that number exists. So we can return 0. Otherwise, if we have traversed whole matrix and we didn't return anything, so that means the number was not present that we were searching for, so we can return simply 0. So that means number is not present. But this solution is a naive solution, so it will take O of n into m time. Why is this so? Because we are traversing all the rows and all the columns. You can see we are using two nested for loops, so the time complexity for first for loop will be O of n, so for second it will be O of m, so it will be combined complexity will be O of n into m. So this will be the time complexity, and the space will be O of 1, because we are not using anything or saving any variable, it is nothing, so we are simply traversing and returning true or false if we have element or we don't have. So what can be the optimal way to optimize, how we can optimize this solution to at least somewhat complexity, that is if we can convert it to something like m to log m basically, because you can see in this array, this matrix that we are given, we are not using the property that is the rows are sorted. So if our rows are sorted, we can do like let's see, so if our rows are sorted, so this is the different matrix you can see, so rows are sorted as we are traversing the matrix, what we can do is add every row, for instead of running this for loop for finding for the element in the row, okay, what we can do is we can simply run a binary search on every row. If we run a binary search on this row, this is a 1D array, you can see we can run the binary search on this array, and for this 15, 25 and 35 and 45 we can run binary search on this, and then again we can run binary search on this. So what we can do is, you can see I've written the pseudocode, so we will traverse all the rows, using the for loop I, and then for every row we will run a binary search if the element is there or not. You can see L will be 0, L will be there, L will be at this point, and H will be m minus 1, that is column minus 1, so it will be at this point. Then we will check while it is less than H. So as you know, as you would be knowing the binary search, actually you would I will link the videos in the description where I have explained the binary search. You can watch it from there if you don't know. So let me give you a brief overview. So you can see, so as our left is here, okay, right is here, we will find the mid out of both. So left plus height L plus H will be giving you the mid, divided by 2 will give you the mid. You can see it will be 0 plus 3, so 0 plus 3 by 2 will be 1, okay, so 1, our mid is at this point. So we will check if this element is equal to the element that we are searching. So it is not equal, so it is less than, so yes, it is less than. So as our array is sorted, so our element will not be at this side, left side, so it will be probably at right side, so we will go to the right side. So we'll increment our left to right plus mid plus 1, so it will come at this point. Now left is here, right is here, so again we will calculate the mid for this. So you can say mid will be 2 plus 3, 2 plus 3 by 2, so it will be actually 2 only, so it will remain at this point, okay. So we will check 30 is again smaller, so we will go to next point. So either if we at any point, like if we will be in this matrix, when we will we will be in this row, that is row 2, okay, in when the I will be at second index, so we will run binary search on this, then we will find our element. So at second index we will find, when mid will be 2, so we will find the element is equal, so yes, element is equal, then we can return 2. That means we have found the element. Otherwise, if we have ended up traversing whole matrix and using the binary search, we have not found any element, so we can simply return 0. That means there was no element present. So this solution will take actually n into log of m time. How it is taking that time, let's see. So as you know, we have to traverse all the rows, so we have to traverse all the rows. So for traversing all the rows, we are using O of n complexity, because we have to use one loop at least. You can see for I is equal to 0 to n, and the time complexity of binary search, as you know, will be log of n. So log of n, so for every column, so column numbers are m, columns are till m, you can see column size is m, so the time complexity for searching on all the columns for a particular row will be log of m. So that is why our time complexity or combined time complexity for this will be actually n into log of m. For first loop it will be n, and for this binary search that we are running, it will be log of m, as the rows are sorted, as you know, and the columns are sorted, so you can use that. Or otherwise you can do that also, that you can traverse all the columns, and for every row, that is this, for every for every column you can run a binary search. That will be similar, but the time complexity will be also similar. Actually it will become m into log of n, so that be so, and the space will be O of 1 only, because we are not saving anything, we are simply returning true or false if we have found the element or not. So let's see how we can get the most optimized solution for this. So if you tell this solution to the interviewer, he will be happy, but he will expect you to optimize it further, because we are also given that rows and columns both are sorted. In this question we are using, at one time we are using only if row is sorted, or we otherwise the column is sorted, so we are not using the both properties together. So let's see how we can do that. So here if you see carefully, we're given this matrix. If you see the last element, so if you take any element, okay, if you take this 20, okay, if you take this 20, so if you see carefully, all the elements on the left side of the 20 are less than it. Okay, you can see all the elements on the 20 are less than it. On this side also you can see all the elements on the left side of 40 are less than it. Yeah, so what we can do is we can start traversing from this side. Okay, if we start traversing from this side, if you see, so all the elements on the bottom of the 40 are greater than that. So if we are searching for 37 and if we see 40, okay, if we like just assume we start our pointer from this point, at this point 40. So if we start from 40 and if we check this x that we are searching for 37 is less than 40, so that means it cannot be at the bottom of the 40. You can see it cannot be at the bottom because all the elements on the bottom of any number, you can see, are greater than that number. So you can see 15, if we see 27 and 32 are greater. If we see 20, so 25, 29 and 30 are greater, because columns are also sorted in increasing order, so all the elements will be increasing. So we can simply eradicate or we can simply remove these elements, so we can remove them from our search space. So what we can do is, now we know that all the elements on this side are greater, so we can decrement 40 or we can decrement our this pointer. Instead of 40 we will come to this point, you can see 30. So now we are on 30. Now if compare this value again, 37 and 30, so 37 is greater than 30. So that means all the elements before 30, because rows are also sorted, so all the elements before 30 will be, as you know, greater than less than 30. So you can see it will be less than 30. So this value will be simply eliminated. So now we can go at the bottom of 30 because the value that we are searching for is greater than 30. So it can be found only at the bottom. Okay, it cannot be found at this point. So our search space, you can see, is reduced by a lot of columns, elements. You can see we were here and we decreased it here, and we simply eradicated all these columns, you can see, and all the one row and column. So now we are on this point, you can see this 35. So when we are on 35 is again greater or smaller than this 37. So again we can remove this. So you can see these are less than 37 or 37 or 35. So now you can see 35 is less than 37. So that means obviously the element 37 is greater than 35. So it will be, as the column is sorted, so it will be obviously at the bottom, okay, or this point. So our search space is limited to this now. You can see now when we increment our this pointer to this point, you can see we increment our row. So we get 37. So that is our element that we are searching for. Otherwise, if we don't have element, any element that we are searching for, like if we have like here, we have 35. Oh, sorry, we have 34, just for example. And if we are trying to search for the matrix for the particular element that is not there in the matrix, so we will end up having our pointers to like out of bounds. Our pointers will go to out of bound. So that will be that means we have not found element. So we can simply turn 0 for that condition. Now here, if you see carefully, we were using all our rows and column properties that were sorted properties. In the lead code, the question is bit different, so you should confirm this from interviewer. In this you can see if we are seeing this element, you can see this 20, so we are not confirmed that this element, where was I? Yeah, you can see this element in the lead code. We are given the constraint that the last element of the previous row, that is 48, will be less than the first element of the next row. But in this you can see 32 is smaller than 48. So here this constraint is less. So in lead code this constraint is also given. So we will use a more optimized approach for this matrix search. So let's see. So do subscribe my channel actually for watching that video also. I will upload in 1 to 2 days. So actually do watch that video also, because interviewer may ask you this question as well as a follow-up for that question also. So you should confirm that from him also. So and you should prepare yourself also for the both questions. So let's see. So the pseudocode for the approach I gave you is this. So let's see. So you can see that we have to initialize our pointer to this point. So it can be initialized as I is equal to 0. You can see row is 0 and column is the last column. So it will be columns minus 1 and I is 0. And we have to run while I is less than rows. Actually we have to search only till the bounds. So it will be I is less than rows. Rows are, you can see rows are 3. Actually I is less than rows, and j is greater than equal to 0, because j will decrement. J will decrement when our value that we are searching for is smaller than this value. If we are searching for 10, okay, so it is smaller than this value 40, so we need not to increment it, because all the elements after 40 will be greater than 40. So we will have to decrement our pointer. So j will decrement, j will come to this point, it will search for 10 then. So it will be like that. And for if we have element like 41, we are searching for 41, so 41 is not less than 40, so we will not go to this point. So we will increment our I. So I will be incremented, I will come to this point, okay, I will come to this point. Now again I is smaller than this, okay, 40, this 41 is smaller than 45, so that means we will go to the left side, j will decrement. Similarly it will be incrementing and decrementing I and j. So let's see the pseudocode. Actually, I will run the pseudocode here also. I will show you the try. So you can see if we find our element, that is a of ij is equal to x, so we will return 1. Otherwise, if our element is less than the element that we are on, okay, if this element that we are on 40 is less than the element that we are searching for, like if we are searching for 48, this 40 is less than 48, so we will not decrement our j pointer. Instead, we will increment our row, because actually incrementing our row will use a property of the column is sorted. Okay, column is sorted. So if we increment our row, so we will go to this, so column is sorted, so this particular column is sorted, so we will go to next point. So 45 is less than 48, you can see. Then we will again increment our j pointer, I pointer. So I is incrementing in the rows and j is incrementing or decrementing in the columns. So now you can see we have found 48. So this will be what our this condition will be doing. And now you can see the next condition will be if our element, else part will be if our element is less than 40. If we are searching for 30 is less than 40, so we'll go to left side. So we will decrement our j will start from here, so j will decrement. So let's see if we are searching for one element. Let's see how we can do that. So I will show you the dry run. Let's see quickly. So if we are searching for value 29, okay, we are searching for value 29. So let's see, we are on this point. We run into this loop. Okay, this condition is true. We check 40 is less than 40 is equal to 29. No, it is not equal. So we'll go to this. You can see else if a of ij, that is 40 is less than x. So no, it is not true. So that means we have removed this. Okay, search space. So now you can see else part will run. So j will decrement. So j will come here. It is on this point now, 30. Now again, if we compare this, 29 is smaller than 30. It is not equal. So this will skip. This condition will also skip. Now we will decrement of j. So j will decrement. Okay, j will come to this point. Now 20 is j is at 20. And I is again, I is still 0. Okay, I is still 0. J is at this point and I is 0. Now if you compare this value 29 and 20, so we will enter into this condition. This a of ij, 20 is less than 29. So we will increment our I pointer. So I will increment. I will come here. Okay, I has came here. J is still at that point. You can see I plus plus. So now 25 again 29. 25 is smaller than 29. So again we will enter into this condition in the next iteration. So again I will increment. So I will come here. So 29. J is still at this point. Now if you compare this value, this condition will be true. A of ij is equal to x. So you can see we have found 29. So we will return 1. Otherwise, if we have not found the element that we are searching for. If you are searching for, you can say 28. So we will come at this point. Okay, 27. Now again we will increment our j this I, because 27 is smaller than 28. So if you see 32 is greater than 28, so we will decrement our j pointer. So j pointer will come to -1. So it will come to -1. So and then our loop will end, and you can see we will simply return 0. That means we have not found element and the pointers got beyond the bounds. So let's see. So the time complexity for this solution will be actually O of n plus m. So how is that? So you can see when we are on this element, we check if the 28 is greater than this element or not. If it is not greater, then we are simply eliminating this. So that means we will not be searching for this. So actually, if you see, we are only traversing the matrix n plus m time, because we are only going, our j is decreasing till it is of size n, m, and our I is of size n. So it is actually going in form of ladder. If you see carefully, it is going in form of ladder, something like ladder. So it will only at worst case also, it will traverse only, you can see, one time. Okay, it will traverse the rows one time, that will be n, and the columns one time, you can see, it will be m. So n plus m will be the time complexity for this solution, as only we are decrementing only j, okay, and incrementing I. So it is like that. So we are not traversing all the elements. We are simply eliminating our elements that we are not searching for. Okay, so let's see the code for this. I will also provide the code in the description. So let's see. So the code for this will be fairly easy. So you can see we are given as the input arguments as matrix, size of the rows and columns, then the element that we are searching for. So we will initialize our pointers. I will be 0, j will be m minus 1. And we will run a loop while I is less than n and j is greater than equal to 0. So we will check if element is equal. That means we have found the element. So we will return 1. Otherwise, we will check if the element that we are searching for is greater than the matrix element that we are on. So we will go to the bottom. If our element that we are searching for, if we are at 40, our element is greater than 40, we will go to bottom. Okay, we will not go to left side. So left side will be smaller. So we will go to the bottom side. So we will increment I. Otherwise, if it is smaller than 40, so we will decrement we will go to the previous value. So it will be j minus 1. So let's make the solution. So I will make the second part for this video, that is using this you can see on the lead code question, that will be also having the constraint for the next element is the next element of the next row will be greater than the previous element row. Okay, so actually sorry for that, I also got confused. So you can see it ran and it submitted. So okay, it's submitted in just 0.08 seconds. So I hope you like this video guys, and do like this channel and subscribe this channel for more such videos and upcoming video also. Thank you for watching guys.